Good morning, Rio Grande third graders. Good to see you here. It's Wednesday. All the snow has melted, and so we don't get to go play in the snow today, but we do get to do some math problems. So let's take a look at our DMA for this morning. Our first problem has to do with fractions of a whole. You will see here that there are two squares, and one is broken up into 4 equal pieces, and the other is broken up into 3 equal pieces. So we want to write a less than, this is a less than symbol, greater than, or equal symbol to make this statement true. So is this piece right here of my square, which is 1/4, greater, less than, or equal to this 1/3 piece of my square here? So what I'm going to do is I'm going to demonstrate for you using some strips here. These are some rectangular strips, and I've got a green and a blue here. So same exact size, same exact shape. I'm going to demonstrate for you first. I'm going to take the green strip and I'm going to cut it into 4 equal pieces. And I do that by cutting it down the middle to make 2 pieces. Why do I do that? Because I want to make sure that each part is equal, and if I take each one of my halves, these are half pieces right now because I cut it into 2 parts for my denominator. Now I'm going to take this half and fold it in half again, and I make sure that these line up, and I cut it. And now I'm going to take the other half and I'm going to cut that one into half again. I'm going to cut this half into half, which makes now I have 4 equal pieces of my rectangular figure. Okay, so I have 4 strips here. Okay, fourths. Each one of these pieces is 1/4 of the whole, which was my whole rectangle. If I put it all back together, it'd be one whole strip of paper again, right? Okay, so here's 1/4. And I'm just going to label that 1/4 here, 1/4, 1/4. Now, I'm going to take the blue strip of paper, which is 1 whole, 1/1, right? If I were going to write it in fraction form, 1 whole. And I'm going to cut it into 3 equal pieces. Now this is a little more tricky because it's not an even number, and so when you have an odd denominator, it makes it a little more tricky. But what I do is I try to get it as even as possible by folding it in here and then making sure that all the parts fold up to that point. And so I have folded it now so that it's in 3 equal pieces. Okay, so there we go. Looks kind of like a patio, right? Or something like that. Okay, I cut that into 1, 2, 3 equal pieces. Here are my thirds. Each one of these is a third, just like I did here on my paper. Now, if I take this 4th, which was green, and I take this 3rd, which is blue, you can see that my 3rd piece is a little bit larger than my 4th piece. Why is that? Because I didn't cut the whole into as many pieces. So when your denominator, if you cut the whole into more pieces, the denominator tells us that we're going to cut or partition that figure into those number of parts. Now, you'll notice that the more pieces I partition it into, the smaller the pieces get. So normally we would say, oh, well, 6, hey, 6 would be a bigger number than 4. However, in fractions, if I talk about 1/6 compared to 1/4, then I should know that a sixth is going to be smaller because I had to cut the whole into more pieces, which is exactly what we did here. We cut this strip of paper into more pieces, and when we did that, the pieces got smaller. So my fourth is smaller than my third. Also, in your fraction bars, you will notice that your fourth is smaller than your third. So when I go to write a symbol in here to compare these two fractions, I know that 1/4, each one of these fourth pieces is going to be smaller than each one of these third pieces, because we're talking about the same exact square, just partitioned into different number of pieces. So I have 1/4 is less than or smaller than 1/3. So 1/4 is smaller than or less than 1/3. Okay, now let's take a look at our next problem. It has to do with fractions as well. And it says true or false, these fraction models are equivalent, which means they cover the same area shown. So in this circle, this is my unit fraction, 1/3, 1/3, and this is 1/3 also. Probably want to do this in pen so that you guys can see it better. This is also 1/3. On this circle, this one whole circle is cut up into thirds as well, and this is one of the three pieces, 1/3, and this is also 1/3. So each of these pieces of my circle is representing 1/3 of the circle. Now they're talking about this shaded piece here and this shaded piece here. And when you compare those, they are the same amount because I'm shading, or I've got shaded in there the same amount of area in that in that shape. So we could say this is a true statement because 1/3 is equal to 1/3. Now the word equivalent means equal to. Okay? The word equivalent means equal to. So, for example, 8 plus 2 is equivalent to 7 plus 3. Why are they equivalent? Because they equal the same amount. They're equivalent to each other. They both have the same amount, or equal to 10. So when we talk about fractions, when we have the same amount of a whole figure shaded in, then that is also an equivalent fraction. And we're going to talk about equivalent fractions a little bit more as we go along in our fractions unit. Okay, let's take a look at number 3. And there are some equations here. So I have two groups of 2. Well, 2 times 2, or 2 plus 2. Two groups of 2 is going to give me 4. 6 groups of blank equals 36. So how many groups of 6 could I add to get to 36? Well, if you know your multiplication tables really well, you wouldn't have to keep adding groups of 6. But if you don't know them, we can keep adding 6 until we get to 36 to see what that missing factor is. So 6 plus 6 is 12. And another 6 plus 6 is 12. So 12 and 12, yeah, you guessed it, is 24. Now I have 4 groups of 6 so far, but that's not 36. That's only 24. And let's add another 6. So I'm at 24. Now add 6 more. That's 30, which is 5 groups of 6. And now I add another group of 6. And now that's 36. So how many groups of 6 did I add to get me to 36? Well, n is going to be 6. Okay? Now, if we know what 6 times 6 is to get 36, then if I add another, so let's think about this. If I have 6 times 6, and I add another one group of 6, this is the distributed property. Remember, we're breaking apart this factor right here to help us with showing that one group of 6 added to 6 groups of 6, which we know is already 36 from up here, then if I add one more group of 6 from one more group of 6 here, then that's going to give me 42. So my product, notice I said product of these two factors is going to be 42. Now, is 42 a multiple of 6? Well, if you count by 6s, then you know that 42 is a multiple of 6. 42 is also a multiple of 7. So when you count by 6s, or if you count by 7s, this product right here should be one of those multiples. Okay, 42. Let's take a look at the next one. And this one's a little different because we haven't really worked with time on a timeline. But we're going to work on that today. Carrie's family leaves at 7:15. So that's a quarter after 7, right? So I'm going to just show you on a timeline what this is going to look like. So let's say I have 7 o'clock here. And then just like if I were working on a regular clock, I could put 7:15, 7:30, 7:45, 8 o'clock, and let's see if 8:15 will be enough. Notice how I broke it up into 15-minute groups because that's what we've been working with, right? On our clocks, every quarter or every fourth of that piece of the clock has been 15 minutes. So I'm going by 15s here on my clock. Now it says that the family leaves at 7:15. So that's when the family left. And they drive for 30 minutes and then stop for dinner. So what time is it when they stop for dinner? So I could count on by 10s onto this. This would be my 10-minute mark right here. So I could take, 7:15. Add 30 more minutes onto this 15 minutes, and that would put me at 7:45. Now this just so happens to work because of the fact that we haven't gone past the hour. And the reason that that works is because of the fact that I haven't gone past 8 o'clock. So just so happens to work here. It will also work here because if I do 15 minutes, if I add 15 minutes here, and then I add another 15 minutes, 15 and 15 is 30. So that also places us at 7:45 on our timeline. So we can see that it matches what we're doing here on our timeline. So today, that's called elapsed time, by the way. Elapsed time, that means how much time has passed. Elapsed time, how much time has gone by. Well, in this case, from 7:15 to 7:45, 30 minutes have gone by. So they will have stopped for dinner at 7:45, and that is going to be p.m. And we know this because we have our clue there, dinner. Dinner is normally at 7:45 in the evening, right? Not in the morning. This would be a.m. then, more like breakfast, okay? All right, today in your discussion, I'm asking you to use the word equivalent, and the word equivalent means equal to. So in your discussion today, go into your Schoology folder. After you've watched the video, you're going to, in your discussion, type equivalent means equal to. Okay? Equivalent means equal to. If you have any questions today, please let me know. If not, have a great Wednesday, and I'll see you guys tomorrow. Bye.